So in this video, we're going to pick up where we left off. In the last video, we looked at the bilinear blending, so how to get rid of that bit-like appearance between the layers and have nice smooth transitions between all of the layers. In today's video, we're going to look at how we can modulate the color of each of these layers inside of Unreal in order to create an appearance that feels more kind of connected, homogeneous, and sort of looks good from every distance. So there's a couple of ways we could approach this, and the first one would be what we did on the actual Project Pegasus, which was to author a global color map in an external program. So we created this suite of tools, the height field materials workflow with a bunch of nodes to manipulate RGB height fields, and we basically authored the global color map inside of Houdini alongside the ID map. And this kind of gives you the maximum control and quality that you might want, since it's very easy to sort of keep adding detail that doesn't even exist in the kind of the ID map between the different layers. But there's another way we can do it, which I'm going to show you today, which is inside of Unreal. We can use a tool called Curve Atlas Tables to tint and adjust the look of each layer. So we're going to be having a look at how do we do that. But to begin with, we're going to hop back into Houdini, and we're just going to get this the actual height field out of Houdini and into Unreal so that our visualization is a little bit more interesting to look at. So I'm going to go and grab the object merge here and grab the raw height field. And then I'm just going to create a file cache node. And we're going to say that we want this to be an explicit cache. So we're just going to name it. I'm going to call this the terrain.bgo.sc. So that's the output file. In fact, let's go and call that the ID map terrain.bgo.sc. It's not a time-dependent cache, so we can untoggle that, and we can remove this last part of the file name. So now we can see that it's going to export in the current directory in a folder called geo, and then it's going to use the name of the project and the name of the node. But actually, tell you what, we're just going to go the name of the node. And if I middle mouse click that, now you can see where this is going to get created and the name of the file that's going to be created. So we're going to go ahead and hit save to disk, like so. Okay, and then I can hit this file chooser to navigate to where that is on disk, back to Unreal, and I'm going to go and filter by Houdini assets. So you need to have the Houdini engine installed, and it's going to be inside of the engine content because that's where I've got, or at least if you've got the plugin installed in your engine content, that's where you need to go. And I'm going to delete the existing terrain. I'm going to drag in a BGO import, and it says Houdini engine session lost. Now, why would that be? Let's have a little look. I'm not entirely sure. Well, we're going to do a little bit of Houdini engine debugging as well today by the looks of it. So I'm going to go to the plugin settings and I'm going to have a little look. It's because I'm targeting my old Houdini install location, and I believe I've now updated. So all I need to do is remove this path, disable, ignore that warning, disable the use custom Houdini location and restart, and I'll pick this up right where we were before. And I'm back. So yeah, I restarted after changing the settings. I will actually just say that simply disabling this didn't work. I did have to target the location of Houdini. So a little bit weird because sometimes that seems to work without the custom Houdini location set, and sometimes you need to override it manually. So in this case, that's what I did. And I've dragged the Houdini BGO import into the world, but it's important to remember, actually, you need to zero this out at the world origin. So what I'm going to do instead is right-click this and go instantiate at the origin. There it is. And before I import anything, I'm going to call this the landscape import or importer. That's also fine. And then we're going to go to that location that we just made a note of. There it is. Okay. And then go to the geo folder, and there's the ID map terrain. I'm going to let this load in. And the nice thing is, obviously, if you're using Houdini Engine, it will import it at the right scale, maximizing the vertical resolution. So that's why we do it that way. Okay, so now we're going to navigate to the folder where we have our ID map stuff. There it is. And because I'm going to live in here for now, I think I can actually just go ahead and sort of hide that little side window. Okay. I'm going to go ahead and apply as well now the material to the landscape, like so. And now we're going to just need to play with some settings inside of the material to make sure that it lines up correctly the way that we would expect it to, the way that we've authored it inside of Houdini. So First thing we need to check is the resolution of the terrain, which is a 500 by 500. Now, how does Unreal like to import that? It likes to import it as a 528 by 528. So I've sort of rushed ahead a little bit here, and I really should have paid more attention to the resolution while exporting. So we're going to quickly find the Unreal Landscape Technical Guide. And this is a nice handy resource that just tells you what are the correct landscape resolutions for Unreal to maximize the resolution quality while minimizing memory usage. We can see that around that 500 by 500 sides, we can use 505. So what I'm going to do, again, I'm going to just quickly go and, where am I going to do this? Probably up here. Yeah, right before we do any of this ID map stuff, I'm going to do a quick height field resample, or even, what resolution are we using here? I think we've got, yeah, okay. So we can see that the height field itself does have a size of 1 kilometer by 1 kilometer. The grid spacing is 2. That's what's giving us the resolution. So we're actually going to set the grid samples to 1009. Okay, so slightly different. We're going to pick the next size up, and we're going to let all of this stuff rerun. So we'll export the new higher resolution ID map as well. So what did we call that? Let's just have a little look on the terrain ID map. Let's go ahead and name that the terrain ID map. So let's use that OS trick again. Terrain ID map.png. There it is. So we'll overwrite that, save to disk. Permission error. All right. So I just need to go and make sure that that's set to not be read only. No, and it's not set to be read only. So why would it not want to save? Failed to modify the parameter because of permission error. All right, so the reason for that, something that we're going to need to change. It's because, in fact, one of these nodes, I suspect, it probably told us which node it was, but when we go ahead and hit save to disk, we're getting failed to modify because of a permission error. It could be a locked asset. It's inside of the height field output hyphen module. Okay, so this height field output node doesn't like being sort of fired off when the node is set to be locked. So what we need to do instead, what we need to do to get around that is go to the type properties, and we need to just, in the editable nodes slot here, type in export. That's the name of this node. Okay, and we're going to go ahead and match the definition, and we'll try again. And you'll see that now it won't complain. So a little update on the node there. And similarly, we now have a 1K version of the terrain. So we're going to hit save to disk. Back to Unreal. We'll delete the terrain, and then we'll just recook the landscape importer. Okay, so now we can see that the terrain has a resolution of 1009 by 1009 pixels. And if we re-import the terrain ID map, we can see the same is true there. And now we can reassign the material. Okay, and finally, we're back where we were, and we need to just change some stuff relating to the resolution. So we can see that there's actually a seam in the middle of the terrain there. You can see there's a line and a line. So that tells me that the resolution is sort of, there's either an offset, so it's either needs to be offset by sort of 50%, or the resolution's off, and my gut tells me it's the resolution. So inside of the material, let's have a quick look at the landscape coordinates. Okay, grid coordinates, landscape coordinates, we can see that the mapping scale we're using is 1, and we're doing a divide by 505 there. So what we should actually do is make this a parameter. I'm going to call this landscape resolution. Okay, and by default, we'll set it to be 1009, which is the resolution of this terrain. Now, once we hit apply, I was expecting to see it sort of snap to the right size. Oh, and I see it's actually because of this, where we've got the divide. So this same divide that we've got over there, pull that over here. There we go. Yeah, so this needs to be applied to all of these divides here as well. Okay, so that's our landscape resolution. Go ahead and hit apply, and we've now got the correct size. That specular is really distracting, so what I'm going to do in the time being is I'm just going to disable the specular completely as well. There we go. And let's try and have a little look, see if we're actually sort of matching this thing up correctly now. So I'm expecting to see these kinds of streaks here coming down the side of that central hill, and I'm not seeing that. So I think what I need to do is sort of provide some kind of offset now. So where we're going to do that is immediately after the landscape coordinates, we're going to do an add, and we're going to create a vector, which we're going to call offset. And then we're going to quickly do a component mask on that. So we're just getting the first two components, the red and the green channel. Apply. I'm going to try and offset that by some factor. So let's try 500 and 500. And that's definitely not the case. So, okay, what I'm seeing is that the offset's probably okay, actually, because we're not getting any seams, which now leads me to believe that it's the rotation, or in fact, we just have not got much clarity on where the texture mask is kind of, we're not seeing those stripes even though we would expect to. So what I'm going to do now is I'm actually going to try to rotate. So I'm going to put down a rotator, like so. And we're going to set the speed to be 1, and we're going to set the rotation as just a scalar called rotation, and it's a fixed value now, so it won't sort of animate the rotation. And the next thing I'm going to do is, because the rotator here expects radians, but it's much easier for my brain to think in degrees, so I'm just going to go degrees to radians, like so. Okay, I'm going to try rotating by 90 degrees. Okay, the next thing I'll try is minus 90. Now, does this look like the right texture? I would say it now it does. And the reason I say I think it now is correct is because there's this sort of shape here that we're seeing clearly represented, light green and yellow. So there's a rotation of minus 90. And why is that? Well, that's sort of a peculiarity of sending stuff from Houdini to Unreal, is that for landscapes, at least using the landscape coordinates node, the UVs of the landscape get a little bit swizzled. I like doing this way with a scalar parameter and a rotation, because I just kind of feel it's more intuitive. But another way of doing a similar thing would actually be to break out the float 2 components and then make the float 2 components again and just swizzle them like so. And if that's not correct right off the bat, it's because we need to invert one of these, like so. Okay, not that one, which means it is in fact that one. And there we see that has achieved the same rotation as this rotator here. But this is slightly less intuitive. And if you were to work this way, what you'd need to do is actually put a static switch in your material saying, I think it's flip 90, or even you would need to have kind of multiple of these, like flip minus 90, you see, and you'd have a slightly convoluted sort of setup inside of your node graph. That being said, it would be cheaper than using the rotator, I believe. But I'm going to stick with rotators because my brain finds that easier to understand. Now, there is another important thing to note here, which is once you start messing with the UV coordinates, if we were to use these as the UVs for our normals, then we would actually have to swizzle the normals as well. Otherwise, we're going to get some sort of shading artifacts. So if we encounter that later on, I will sort of show you how we address that too. All right. So we've got our material, we've got our texture atlas array. We haven't necessarily picked the textures that make the most sense for each surface, so that's something else that we would likely look at. But what I'm going to do now is what I promised at the start, which is looking at how do we do some color grading or some color correction. And what I'm going to use to do this is I'm going to create a new kind of asset. I think it's under miscellaneous. Yep, there it is. So we want to create a curve atlas. That's the one. I'm going to call this curve atlas. Let's go with grading, just keep it nice and simple. And we can just go ahead and sample this guy inside of the material as a texture. Okay. And what we're going to do now is, again, go to miscellaneous, and we're going to create a curve. And we want it to be a curve linear color. I'm going to say C color. Okay. And then we're going to go into the grading asset. We're going to set the texture width to be 256. That gives us 256 sort of gradings. It's like the gradient has that many different colors on it. But we don't need it to be square. We can make it be this just a long strip, like so, with a height of 1. So we're going to go and then add one curve to it. We're going to add our color curve to it. We're going to go back into our material. We can see that's now populated with that grading. And to begin with, we can just do a straight up multiply these two. And this isn't what we're not going to leave it at that, but I'm going to start with that so we can see what's going on. Okay, so not much has changed. And why is that? Well, it's because we need to wire something into the UVs. We can see that if we start previewing, if we imagine the X and Y, or the U and V coordinates, the lower we are in U or X, the darker we are, so the more to the left of that gradient we are, and the higher we are in U or X, the closer we are to white. And let's just go ahead and add a third color in here to sort of make things a little bit clearer. In fact, let's go with a good old RGB gradient. Okay, R, G-ish, and B-ish. Okay, so now we can see everything's being tinted blue. And there is our curve atlas now inside of here. So we need to construct some UVs that make sense. And we don't really care about the Y coordinate because we're just using the one-dimensional gradient here. You could, of course, have more gradients. You could create a sort of, a two-dimensional sort of selection tool, which could be quite interesting. But in this case, we're just interested in one. And I need to construct these UVs. So how am I going to do that? Well, I think what we're going to do is we're just going to grab one of these samples. Let's actually go with, let's just go with a new sample, and we're going to grab the coordinates, but without any offset, because you can see all of these ones have an offset. Okay, so we need to make sure we're dividing the size by the appropriate amount, like before, to ensure that it fits onto the terrain. And then we get our result from our sample. Now, at this point, we should remember that we have created how many layers? We've created, well, we're using five, our maximum ID map value is 5. And back inside of Unreal, we can see that that means it's pretty much pitch black. So out of 255 values, we're just going to be between 0 and 5. So what I want to do is I want to stretch this to sort of fill out the full 0 to 255 range, or the full 0 to 1 range. So I'm going to grab, and we're going to just set this to be, for now, just M for multiplier. We'll give it a better name later. And let's have a little look at what we're getting. So let's times it by 15. And let's temporarily just unplug the UV so we can see what we're looking at in the shader. And we can see that, as we multiply it, it gets brighter. But we don't want to multiply it by some random amount. We want to sort of stretch this across that 255 range. So the way that we do this is we just make sure that we input the sort of number of ID map layers, which we know to be 5. And then because we want it to be some factor of 255, we're going to put in a divide, 255 by 5, and then that's the multiplying factor that's going to ensure this range goes between 0 and 1, which means that we will have a color, a different point in this curve atlas will be selected. There we go. And then I need to fix those UVs for the ID map. And we now have the ability to tint differently all of those different kind of parts of the ID map. So we can sort of open up our curve here, and we can sort of forget the curve atlas table and just care about the curve now. And you can see that as we sort of drag this here, we can tint differently the different parts of the ID map. And because we have currently 5 ID map layers, we could sort of roughly aim to sort of divide this into 5. So we've got 1, 2, 3, 4, 5. Okay, so this is obviously a little bit rough, But what we can see is that this does give us the ability to tint each of those layers interactively inside of Unreal here. And better ways, sort of more advanced ways of setting up similar tooling like this would be to create a utility widget, sort of an editor utility in Unreal, which is totally feasible and easy to do, and to create a kind of interface based around sort of tinting each individual layer. And that's absolutely something that's possible to do. And maybe at some future date, I'll release some videos showing how we sort of set that kind of behavior up. So I'm just going to play with this here a little bit more and sort of try and find something that I think is sort of just holding together a little bit better than what we had previously. I don't really want to take everything too far away from its original color, so I'm actually going to desaturate all of these quite a bit. Now, obviously, this doesn't look great, but I'm going to call it a day there for the time being. And what I'm going to draw your attention to now is that we're kind of back where we started with this kind of weird squiggly lines between the different tints. So how do you think we're going to solve that? Well, we're just going to replicate the kind of setup that we did up here with the color map samples. Okay, so yeah, we can delete our sample here because that's just a one-off sample. And we're going to, I actually need to keep the, yeah, no, where am I going? Yeah, we need to delete this sample over here, but we need to keep the multiplying factor. There it is. And there's our sample. So we're going to have to now sort of replicate this a bunch of times. And we're going to grab our samples. So what we're going to do is just sort of wire this out, create a named reroute. I'm going to call this A. Create a new one, named reroute. B, named reroute. C, named reroute. D, okay, like so. Like so. All right, and then we're going to get A, B, C, D. We only need this parameter once. Multiplying factor. Oh, no, that's right. That's right. There we go. In fact, we only need this once as well. Okay. And then we've got our A, B, C, and D. Okay. And then we're going to go ahead and copy this whole chain of logic. Check all of this. C, D, and then I'm going to wire the result into the multiply. Hit apply. And now we can see we get that nice smooth blending, and our tinting still works the way we expect it to. So let's have a little look. Bring that up to say 3, 1.3. Bring it a bit more to sort of the green range. There we go. What else have we got? We've got this guy. I think we need to tone you down a bit. Is that what we need? Maybe we need to change the tint a little bit. Oh, I don't know. I'm fighting a losing battle against my artistic skills here. But I think that we can leave all of that stuff in the mainline series. So I'd recommend you, obviously, if you haven't already watched it, you go and check out the main Pegasus landscape series, where I show you how to kind of work with our content that we've created for Project Pegasus. This is really just intended to be more of a technical kind of deep dive into cool material tips and tricks. And I'm not really wanting to show you absolutely sort of every stage of setting this material up, but instead kind of giving you the broad strokes. And basically now what I would do, maybe what I can give this to you as kind of a homework or a challenge, is how you might think about sort of reorganizing this material, maybe breaking certain aspects of it up into functions in order to sort of avoid very repetitive, you can see very repetitive kind of structures or the recreation of redundant sort of node chains. So how you might break this up into some functions in order to sort of keep your workspace a little bit clean and tidy. All right, so that was how we add tinting to the color directly inside of Unreal. Thanks for watching, and we'll carry on sort of figuring out how to sort of improve this material in the next one.